So that is about me. I've been a consultant since 2001, author and speaker. You notice the things that I do tend to be data-oriented, but unfortunately, I'm unable to focus on a single thing, so I also do healthcare data integration using the Health Level 7. It's one of the contributors to the industry standard data model, HL7 reference model. I do requirements modeling and business analyst training. And you'll notice that none of the things there relate directly to ontologies. So I don't claim to be an ontologist, but I picked up some information about that, and they've intrigued me, and I believe it can really help us as data modelers. So the goals that we publicly presented is that you would learn about 2 high-level ontologies, and we'll learn about what high-level ontologies are very shortly, how they can significantly enhance your data models, and 5 tips that data modelers can adapt from ontologists, and learn what ontologies will not do for you. Now, I have to confess that my real goal is to convince you that all these things are really true. And we'll see at the end if you agree, if I've been successful. So roughly, we'll look at the definition of an ontology. We'll look at 2 definitions, as a matter of fact. We'll do some terminology setting, because ontologies use different terminologies that we use in data models. I want to show you the comparisons so that the terms don't freak you out. Then we'll look at 2 high-level ontologies. One is called GIST, and the other is called the basic formal ontology. And I've deliberately ordered those in that order. I think the GIST one is the one you will relate to most easily. And the basic formal ontology may be a bit challenging because they use different terminologies. But that's deliberate, and you'll see why. And it'll do a summary. So my disclaimer is all the diagrams and examples that I'm going to be presented are abbreviated to fit on a slide. PowerPoint is a horrible way for doing diagrams, but it's what we have. So why should you care about this stuff? I'm claiming that ontologies may have already defined some of the entities that we need in our data models. They may have created high-quality definitions that you can just utilize or at minimal adapt. And finally, they're growing in popularity and in volume and in quality in many areas. And so some of those may be able to help you quite a bit well. So here are 5 questions. At this point in time, they're really rhetorical questions for you. However, I'd like you to keep them in mind, because I'm going to ask the same set of questions at the end and ask you for the answers. So are ontologists data modelers? Kind of. Good. All right. So we've got someone that thinks that's good to hear. Are data modelers ontologists?
Yes.
I heard yes, and I see some no's. This is going to be really good. Have they already?
Well, we got this side and that side.
Yeah.
So we're saying it's not a super type subtype relationship.
Well, we will get into that very quickly here. So have ontologists created ontologies encompass many of the concepts we need to include in our data models? Should we incorporate some of their ideas? And what can we learn from ontologists? So keep those in mind, because I'm going to ask you to answer those at the end. So we'll look at 2 definitions that I've pulled that I like, and they're somewhat different. So the first one is a formal, explicit description of concepts in a domain of discourse. And ontologies call the concepts classes. Properties of each concept describing various features and attributes of the concept. Think of properties as attributes in a data model. And restrictions on properties. An ontology together with a set of individual instances of classes, think of those as instances of your entities, constitute a knowledge base. So it's not just the model, but also individual instances that constitute a knowledge base. Here's a second definition. A representational artifact, think of that as a model, comprising a taxonomy as proper part. Think of taxonomy, substitute hierarchy for that, whose representations are intended to designate some combination of universals. Think of that as your entities, defined classes, and certain relations between those. Think of those as relationships in your data models. So those are definitions, but we'll look at some examples and help and make those a lot more clearer. So I thought that for this group, I would draw some analogies in some of the terms. So how many are familiar with Len Silverson's universal data models or have heard about them? Okay, so for those that have, you know that the Data Model Resource Book Volume 1 is full of generic patterns that are not specific to one domain. They include things like party and role and things like that. So in ontologies, those would be called former or upper level. And both of the ontologies we're going to look at today fall into that range. In his second volume, resource book, those are application or domain-specific models. So he's got one for healthcare, manufacturing, and I don't remember what the others are. So in the ontology world, they call those material or domain ontologies. Now, I'm also going to do a comparison between terms we use in data modeling, and I'm also going to include UML and ontology so that you see the difference. So we all know what an entity is. In UML, they call that class. In ontologies, they call that a class or universal. You will hear both of those terms used. And we've got entity instances. In UML, those are objects. In ontologies, they're called instances or particulars. We know about subtypes and supertypes. In UML, there's a generalization relationship. And ontology, they call it an is-a relation. We know about attributes in data modeling. They're known as attributes in UML as well. And they're called properties or slots in ontologies. Attribute values are the same in UML and data modeling. And they're probably called property values in ontologies. And we know about relationships in data models. They call them associations in UML, and they call them just plain relations in terminology. So that's just an overview. Now for the first ontology. I'm going to stay on this side for now. So this is GIST. It's an ontology that was developed by a company. And by the way, both of these are all available for public download. We've got references. You can see where those are now. And for those that are looking for more information on GIST in particular and on representation of ontologies, Mark Uska is giving a workshop on Friday. And Mark is one of the people who works for the company that created GIST. So here's what they call their ontology. They say it's a minimalist upper-level ontology. So it's like the universal data model patterns. They say it's designed to have the maximum coverage of typical business ontology concepts with the fewest number of primitives and the least amount of ambiguity.
What was primitives again? Sorry. What did that mean again?
Primitives, I think, it just means the fewest number of entity types.
Abstracted out.
Yep, okay. Yep. So for each of these ontologies, we're going to look at, we'll give you a definition. We'll look at a diagram. In one case, it's more than 2 diagrams. That will show you the entities. And just like a data model is not just a diagram, after that we'll look at the definitions of some of the entities, some of the classes in there. And then we'll look at identifying and definitions of some of the relations. So here is a diagram, high-level diagram